Hello everyone, it's July the 1st. Intersection of two arrays. Two arrays, an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and then you may return the result in any order. Any order. I think you can you sort both. Of course, you sort both and you have 2 pointers. Just go through them one by one, right? And yeah, you sort them and then you just move. And if they're equal, you move both. If one is smaller than the other, the smaller sides go. So yeah, I can do that. This is a good question. num1 size is small compared to num2. Yeah, and I think we just go through num2 and then just check on num1. We can do that. Or we can do great. Or we can do extra space, right? We can use a counter. We can do that as well. So the small one we can either sort it. Actually, no, not really sort it. But create a counter. You cannot load all elements at once. Stored on disk. Well, you just go through them one by one, and so one of them has to be loaded in memory. All right. Yeah, I think that should be right. Okay, but anyway, this we'll do the easy way around.
No es cuenta, it's a card. My gosh, issues. How do you know this is not private information? You should have sent the number.
I don't feel like. No. Alright, so we're done with this. Let's move on. Minimum edge weight equilibrium queries in a tree. There is an undirected tree with n nodes labeled 0 to n minus 1. You are given the integer n and a 2D integer array. Okay. UVW indicate that there is an edge node, a UV, and a weight. You're also given a 2D integer array queries of length m, where queries AB. For each query, find the minimal number of operations required to make the weight of every edge on the path from A to B equal. In one operation, you can choose any edge of the tree. and change its weight to any value. Queries are independent of each other, meaning that the tree returns to its initial state on each new query. The path from A to B is a sequence of distinct... I'll wash the dishes. The path from A to B is a sequence of distinct nodes starting with node A and ending with node B, such that every two adjacent nodes in the sequence share an edge in the tree. Answer I is the answer to the ith query. Hold on. Path from A to B is a sequence of distinct nodes such that every two adjacent nodes in the sequence share an edge in the tree. So we have this. So we say 0 to 3 is 0. 3 to 6 is 0. 2 to 6 should be 1. And 0 to 6 shall be 3. Okay, query 4 to 6. 4. Because it's a tree, right? Yeah, undirected tree, so there's always only one path. So 4 to 6 is 1. 0 to 4. Where is 0? 0 to 4 is going to be 2. 6 to 5. 2. 7 to 4. Huh. 7 to 4 is 3. Weight is not more than 26. That is a hint. Weight is no more than 26. It's like letters. So you can use A, B, C, D to represent the weight all the way to Z. How does that help us? So what we want to know is each path. Yeah, we definitely cannot go through all the paths. But each path, I want to know. Well, the path can be represented by yeah, I mean, what if we just pick anything as a root? Okay, so we pick 0 as a root. I'll pick 1 as a root, doesn't matter. 1, 2, 5, 4, 3, 6, 0, 7. It doesn't really necessarily to be a binary tree. It doesn't say it's a binary tree. Welcome.
Oh no.
Oh, I found it. The little piece of paper I've been looking for. I don't know, it's just like my pens fall to the floor. I move my pens and this one just showed up.
On the floor?
No. Well,
Mary had it in her pocket or hoodie?
maybe it just fell inside. Yeah, that's likely. So if I assign a letter to everyone, and that's the hint, right? So 4 is A, B, C, 4 is D, 6 D, E, F, 3 A, B, C. This is F, F again. If G, H, A is B. Okay. So if I do this, then each node will have a letter, right, pass. So I can say, I don't know, 2, right, 1, root is 1, 2 can be F, 5 is FC, 4 is FF, 3 is D, 6 is DF, O is DH, not O, 0 is DH, 7 is DHB, right? If I do this, will this help? It's like a try, right? But let's say we want to find, I don't know, 625. We want to find 625. How do I find 625? So we find 6. 6 is DF. And 5 is FC. We need a uniting thing at the start, so we know this is where we start. But it's fine. It's always start is the same, right? But how do you know that they are on different sides? Like I can say 6 to 7, right? 6 to 7. If I do 6 to 7, I'll check 6 is, so we'll say root is actually 1 to 6, and then 1 to 7 is DF is DHB, which means I can say the first step is the same. So 6 to 7 must be the combination of this. But that's not necessarily true, because if this is F as well, then it might overlook. So we're trying to say, how do you know they're the same, right? Like if it's on the one side, okay, I agree. We might be able to, all these can be overlapped. But if they're on different sides, right? What if this is F as well? What if, right? Then 3 becomes F. Like all the D's become F. All these D become F. Now if I want to do 65, right? 625, it should be FF. 6 is FF. This is F5, FC. Then I say F the same, that which is F and C. And that's not true, because these two F are different. So I just need to know how to, like, I can do all these paths, right? But once I do all these paths, how do I quickly find out, given 2 nodes, I need to know this path? So yeah, so that's the question. Given 2 nodes, how do I know the path? I think I've done this before, right? Given 2 nodes and immediately know its path. Given 2 nodes. It might as well just record its path. Record its path. But still, even if you do that, I don't know. If we do, 1, 2, but that's 10 to the 4th. Ugh. 5 is 1, 2, 5. Like if I do if I need to know 2 to 5, how do I tell from this quickly? Yeah, I need something like O1. Right? We can do ON to get all the paths starting from our root. And then, given any 2 nodes, I want to know their path immediately in O1. Is that even possible? Technically, no. Like, you'll still take on to find the path, which is not what we want. Right? This is not what we want. Because the query length is 2 times 10 to the 4th. So for each one, we have 2 paths. I don't know, maybe it's 10 to the 4th, I don't know. 10 to the 4th, maybe it is the way, you know? Maybe it is the way, right? All we want to know is the path, right? All we want to know is the path. And yeah, we do it this way. And then if I need to know, 2 to 5, I get a path out. And then I just start go find the first one that they're not the same. In the case same, boom, they're not the same. So the path will be this and yeah, so eventually will be like there will be something last. This is a common ancestor, right? So it's from a common ancestor towards this plus common ancestor towards this. So we can do that in O. Well, technically, yeah, O. If you have like just a long thing, right? Then yeah, you will have to go through every one of them. It's gonna time out. I feel there's definitely a better way to approach this. If this is a way, right? This is a way. I think we should, even if it's gonna time out, we should try it. And if it times out, we think about something else. What I feel is we probably can, work a little bit on the queries. Instead of calculating everything from scratch, we work on it a little bit. Like in this query, right? Like in this query, we have 4 appearing so many times. And it doesn't really matter from where to where, it doesn't really matter. So maybe we can sort the queries, okay? We sort the queries, okay, within the query you always go small to large, and then we sort it, right? We sort it. Then we'll have from something, right, to something, and then we can, observe if there is from something to something, and as we go through, I don't know, is that gonna help? Like in this case, I have 4 to 6 and 4 to 7, right? 4 to 6, 4 to 7. It doesn't really help much, right? It doesn't really help much. Like at the end, what we get is just, 4 to 1 and 3, 0, 7. And we'll collect all of these, and then we'll count. It could be OM times N. It is OM times N. Yeah, I don't think OM times N is the way to go. What's the topic here? Strongly connected component. Don't know what that is. Alright, anyway, well, give us some time to think about this. Alright, see you guys tomorrow. Adios.